Let's talk about section 2.6. When we talk about division, we're really talking about the multiplicative inverse. And the multiplicative inverse is really just the reciprocal of a non-zero number. The number and its multiplicative inverse will always have a product of 1. Remember, that's what we talked about when we talked about that multiplicative identity is 1. So the multiplicative inverse is what do we do to get back to 1? Additive identity was 0. What do we do to get back to 0 was the additive inverse. That was opposites. In multiplication, it's reciprocals. So A times 1 over A. Remember our multiplication rules. We'd multiply straight across. We'd get A over A. And that was what would get us a 1. This is the Y. You don't need to show me that. I put it into our notes so we could see it. So the same thing's going to happen when we go over here. 7 times 1/7 gives us 7 over 7, and we know that's equal to 1. Negative 10 times 1 over negative 10, or even negative 1/10, because that negative should really be in the numerator on a fraction. It really shouldn't be in the denominator. But for the sake of this example, negative 10 over negative 10 to give us a 1. So my multiplicative inverse, these example problems, I'd like you to go through and work on example 1. I only want you to do parts A and B on your own. Remember that the multiplicative inverse is its reciprocal, and the reason is your support, like I showed over here. So that's our reason for the sake of our notes. Letter C, after you finished A and B, come back, and I want to talk all the way through letter C because there's a common mistake, and I don't want you to make it. So now we're back and we're looking at question C. Notice that I moved my negatives in problem B. I kept them both in the numerator. So instead of getting negative 30 over negative 30, I got positive 30 over positive 30. Either way is okay, because either way I get a positive 1 when I get to my answer. In letter C, I want to put down a bad answer. Ooh, I'm going to change to red for my bad answer. If you were to write down 2 and 5/3, this would be wrong. Very wrong, wrong, wrong. You didn't consider the whole number. You only considered the fractional piece. And 2 and 5/3 is not an acceptable way to write an improper fraction. When you're given a mixed number and asked to find the multiplicative inverse or the reciprocal, what you need to do first is to change it into an improper fraction. So we do the whole number times the denominator, that's 10, and add 3 extra pieces or 3 extra fifths. So we end up with the fraction is 13/5. And now we can do the reciprocal. The reciprocal, or the multiplicative inverse, would then be 5/13. And the reason is because when I multiply 13/5 times 5/13, I get 5/13. I do in fact get, what is that, 1565 over 65? So that is in fact my 1. Now when we look at this, the reason behind it, why are we talking about all this multiplication? This section is about division. By definition, division is really a fraction, right? To divide a number A by a non-zero number B, multiply A by the multiplicative inverse of B. So when we look at A divided by B, it's really saying that we should take A and multiply it by the reciprocal of B, which would be 1 over B, which is why when we see that division bar, we can change to a fraction, A over B. Or if we were looking at a number, we would say 7 times, instead of 3, 1/3, and when we multiply, we're going to get 7/3, and that will be just fine. The last piece there is about the sign of a quotient. Remember that because division really is multiplying by reciprocal, then our same rules as multiplication. So quotient is that division word, and if I have same signs, my result is going to be, or my quotient is going to be positive. Quotient with different signs is going to give me a negative result. Here's an interesting one. The quotient of 0 in any non-real number is undefined because 0 does not have a multiplicative inverse. So that what this is really saying to us is that if we end up with a 0 in the denominator, this fraction is undefined. You have 4 examples here. Give them a try, and then blip back and check your work. Hopefully you didn't have any trouble doing these problems. I want to point out a couple of pieces. First, in problem B, that I went ahead and simplified before I multiplied across. If you chose not to do that, that's fine. Just make sure that you simplified your fraction. The second that I want to show is right here when I did the reciprocal of -4. Notice again, I put my negative in my numerator so that I ended up with a negative times a negative equals a positive. If you did this problem slightly differently and you said -1/7 times 1 over -4, if that's what your problem looks like, then you ended up with -1 over -28. Please make sure that you went back and you adjusted. A negative over a negative becomes a positive answer. So 1 over 28 is still your answer, even if your work is slightly different. See you in the next one.